I'm Scott Schiffres. I'm an associate professor of mechanical engineering at Binghamton University. And my area of research is additive manufacturing and heat transfer. Our tech that was funded by TAF is basically addressing a problem of powder feedstock quality for additive manufacturing. So when you print something with additive manufacturing, the final part is only as good as your initial material that you print with. There's several different additive manufacturing techniques that are used commercially, and the one that this technology is focused on is the technology that uses a laser to basically fuse and melt powder into a solid part. And this technology is used quite widely for aerospace and biomedical applications. So what we're trying to do is find a good way to detect the quality of the input to 3D printing before the part is printed. Right now, the way that companies address the quality is very imprecise, and our technology can help measure the powder quality in the device. I just love playing with machines and working in the lab. And it's also fun, it's a team project, working with students and my colleagues. It would be really great to have technology that came out of the lab actually in metal 3D printers. I think one thing that's very unique about the TAF funding is it really is focused on the commercialization. We have some funding from NIST, which has been great for developing the technology, but what TAF is really valuable for us is actually getting the technology out to be commercialized. If anybody's interested in partnering or collaborating on this research from industry, feel free to send me an email at sschIffr@binghamton.edu.